Math 10. So we are continuing along with our unit number and exponents, and we are doing lesson 4 now, which is on the number systems. So remember I said lesson 3 and lesson 4 are sort of one concept. Lesson 3, the only thing you have to know is rational and irrational numbers. Lesson 4, I'm going to take it one step further. This is a pretty quick lesson in the sense that we only do actually half the lesson that you need to know. So I want you to find just a little place to write, because we're going to review quickly what we did on lesson 3, and I'm going to show you the new concepts for lesson 4. So I want you to write the number systems either on a separate sheet of paper, or you could write this at the beginning of your book, anywhere you could write. So, or if you write really tiny, it could fit at the top of your page. So remember that I told you that in lesson 3, I could give you any number, throw any number at you in the world, and those numbers will fit into one of two categories. And the numbers are either going to be, it's either going to be rational or it's going to be irrational. And remember that rational, I told you all fractions, right? So all fractions are rational. And then we look at the decimals of the fractions. So 0.25, it's going to be a terminating decimal. So if a decimal terminates, it's going to be rational. And 1/3 is also going to be rational because that decimal repeats. So with rational numbers, if the decimal either terminates or repeats, it is going to be rational. Any fraction, of course, is rational. And remember, I could throw a number at you like 7 or -7 and say, is that rational or irrational? And you'd say, well, I could put that over 1. It's rational. The irrational numbers, to review from lesson 3, are the ugly numbers. So what's ugly? So I told you pi is ugly and the square root of 2 is ugly. These numbers, their decimals never terminate, they never repeat, and they can never go into fractions. So that's all you need to know about irrational numbers. What this lesson is going to be on is we could actually break the rational category down. So within my rational numbers, there's subsections, and you need to know these subsections, and there's 3. Those subsections are, they're called the natural numbers, whole numbers, and integers. So the only thing I'm literally going to teach in this lesson is what is a natural, what is a whole, and what is an integer. You have to have a really, really good understanding of that. Those are all rational numbers and nothing new about irrational. We are done with irrational, those ugly numbers that never terminate, never repeat. Okay, so let's go through these 3 definitions, and then we'll make some charts, we'll look at examples, and I'll give you your homework. Okay, so I want you to take out your highlighter, and I do want you to highlight natural numbers, whole numbers, and integers. Okay, so you have to know these 3. And again, I'm going to give you a couple tricks to remember these. For natural numbers, I call these kids counting numbers. So write that down. And I want you to write this. Just write this. Ask, how do kids count? Kids count. If you remember kids counting numbers, you're going to remember natural. So if you guys have a little brother or sister at home, let's say they're 4 years old, and you say to your little brother or sister, count to the number 5 for me. I don't know why, but all kids, when they start counting and you ask them to count to the number 5, they will all start at the number 1. 2, 3, 4, 5. When kids count, they start at the number 1. They never start at the number 0. So the very first or the lowest natural number is 1, and then 2, and then 3, and then 4, and then 5. Okay? Those are the natural numbers. It starts at 1. Whole numbers, circle the 0 in whole. Whole numbers start at 0. 0, 1, 2, 3, 4, 5. So, and it goes on and on and on. So, for example, now you guys, if I gave you the number 6, and if I said, well, what is 6? You would say it's either got to be rational or irrational, right? This is a nice number. This is a beautiful number. This is a rational number, right? Because I could write it as a fraction. So it's a rational number. Then you need to be able to tell me from the rational numbers, we've got these 3 that they could belong to. They could belong to 1 or all 3 or none. And I'll give you an example. So you'd say, is this a natural number? Is 6 a kid's counting number? Yes, 6 is a kid's counting number. Is it a whole number? Yes, whole starts at 0. So it is, this guy we would say is rational, and then we would say it's natural, and then I would add now whole to it, right? Now, the integers are the positive and negative numbers, including 0. So we've got 0 in the center, and then 1, 2, 3, and all the positive numbers, and then the negatives to the left. -1, -2, -3. Okay? Oh, and it continues forever in that direction. So those are the integers. Now, is 6 an integer? Yes, because if I keep going in this direction, 6 is an integer. So if I give you your number 6 on a test, you can no longer just tell me it's rational. You'd actually get 4 marks for the number 6, or maybe I'd give you 2 marks for this. 0.5 for saying it's rational, 0.5 for telling me it's natural, 0.5 for telling me it's a whole, and it's an integer. Now, one super important thing to star here is these 3 numbers, natural, whole, and integers, no decimals. Okay, no decimals. So for example, if I gave you the number 1.25 and I said, is that a rational? Okay, is this rational or irrational? You should say it's rational, right? This is a nice, pretty terminating number. It is rational. But then if I said, okay, break 1.25 down, is this natural, whole, or integer? It is neither of those. This guy would be rational, and it can't be either of these because these have no decimals. Okay? Now, one other thing, your book and various textbooks, and when you get to university, they will often use the letter Q to denote a rational number. And they will say that an irrational number is a Q bar. So in your homework, if they say, what are all the number Qs, they're asking what are the rational numbers. So Q is rational, Q bar is irrational. And remember, Q, if it's rational, it could be a fraction. And if it's Q bar, if it's irrational, those are ugly, right? Why are they ugly? Because their decimals are non-terminating and non-repeating. Okay? So let's do this Venn diagram. They love giving Venn diagrams on tests. The numbers, you guys, that I will throw at you in grade 10, 11, or 12, they are called real numbers. Okay? It's all the numbers in our number systems. There's 2 types of real numbers. They are either going to be Q or Q bar, right? So I've just divided all of the numbers fit in this box here in our world in grade 10, 11, and 12. And they're either going to be irrational or rational, right? So, and the reason why I put rational over here is because I know that like the wholes, the inch, like that's going to go here. So let's do our irrational numbers first. So our irrational numbers, our famous ones, are pi and the square root of 2. Those are our irrational numbers. Now, what goes in the middle here are our natural numbers. Those are our kids counting numbers. Remember the first subset of rational, it's kids counting. And where do kids count? What number do they always start at? They start at the number 1. So I'm going to put a 1 in here. Oops. Okay, I'm going to put a 2. I'm going to put a 3. Any number that any number, like any number that's not a decimal, 1, 2, 3, 4, 5, 6, whatever, that fits in here. Now, whole numbers. Whole numbers include the natural numbers, right? Because if I go back to whole numbers, these are natural numbers, those 3. What's the only whole number that exists that is not a natural number? It's this guy here, 0, right? So the only number that I'm going to write in whole numbers is the number 0, because what you need to see is the whole numbers are 0 plus all of these natural numbers. Okay? Now, out here are the integers. Now, the integers, what do the integers include? So if I look here, I've already got the integers include my whole number, which is 0. I've got that listed. I've got, it includes the natural numbers. I've got those. So now I just need to take care of the negatives, right? So I'm going to put -1, -2, -5, -11. Those are my integers. Then outside of the circles, but within this box, these are my rational numbers. So those are Q's. Like these are all going to be rationals. But what numbers are not, what are rational, did I say? But they wouldn't belong to integers, whole or natural. Those are any of your decimals. So for example, 0.5, which is 1/2. That is a rational number, but it's not natural, whole, or integer because it's no decimals are allowed. Or the other one I'm going to write over here is 1/3, right? 1/3 is 0.3 repeating. That guy is a rational number. I can't put decimals in these 3 subsections, so it would go in my rational bar, okay? That is essentially this lesson. We're going to do some question, like one more question, and then I'm just going to give you your homework. And if you get this, then that's it. Okay, let's do the one and only class example. So, okay, number 1. For each of the following, write all the set of numbers to which the given number belongs. Write the answers from the largest set to the smallest set. Okay, I'm not going to worry about writing the answers from the largest set to the smallest set. So remember that, just to go through this really quickly, we've got our rational and our irrational. And then rational, there's 3 subsections. Natural, which are our kids' counting numbers, 1, 2, 3. Whole, which includes 0. And integer. Okay, so the number 9 can be written as 9/1, right? That is a rational number. What else is it? Is it a whole? Is it a natural number? Is it a kid's counting number? Yes. So it's natural. Even you guys, if I gave you the number 1,000 and I said, is that a natural number? Some students might be like, oh, kids can't count to 1,000. I could give you like the number 1,000,000. It's still a natural number, okay? It's also a whole number because whole includes 0. So it's going to be a whole as well. And 9 is an integer. So number 9 on a test would be worth like either 4 marks or it'd be worth 0.5, 0.5, 0.5, and 0.5. This guy here, I know right away it's a fraction. This is going to be rational. I don't care what the decimal is, it's rational. If I look, let's look at the decimal. 11 divided by 7. Oh, it looks, you guys, ugly, but there's going to be a repeat in here. 571,428. 571,428. 571,428. Okay, now, is this guy natural, whole, or integer? It's none of those. Because remember that if it's a decimal, it's only going to be rational. It's only going to be rational or irrational if it's a decimal, right? Okay, so these can't have decimals. This guy here, square root of 5, looks to be irrational. Let's check if it's irrational. It is. This guy's irrational. Okay, -7, I could put that as a fraction, so that's going to be rational. Now, let's look at the subcategories. Is it natural? Kids' counting numbers start at 1, 1, 2, 3, 4, 5, 6, 7, so it's not natural. Is it whole? That starts at 0. It is not whole. Integers includes the positive and the negative numbers as long as they're not decimals, and that guy's not a decimal. It is an integer. Okay? Um, that is going to be it for this lesson. I'm going to give you your homework, and I'm going to change a couple things in your homework. Um, so let's circle 1 to 4. Let's look at number 4 because I wrote test, and let's circle number 14. So you guys could skip this. We don't have to, that's beyond our curriculum. This guy's beyond our curriculum, as is this. Okay? Extension, we're going to do absolute values in grade in 20-1, or if you're in my AP class, I'll teach it to you then. Okay, so let's circle these numbers. So 1, I want you to do. And remember that that's obviously going to be our rational. This guy's going to be our irrational, Q bar. And then I want you to fill this in. See if you're able to do it without looking at my notes, and then look at the notes if you need to. Okay? Remember if you want help, the very middle is the kids counting. Then it goes the whole because the whole includes 0. Then it includes the integers. And I want you to give examples. So like write the examples that we did. Okay, circle number 2. And for number 2, I want you to cross out this guy. It's a bit of a trick, and I don't like the trick that they do, so I don't want you to do that one. The number 0, you guys, you can put it over 1. So we know that it's rational. Now just figure out, is it natural, whole, or integer, or all 3, or none of the 3? You guys figure that out. So number 2, do everything but C. I want you to do number 3. That's a good AP question, explaining. Okay, number 4. Oh, yes. I'm going to give you a test question, and you're going to get a chart, and you're either going to click off, you're going to click this. So I'll show you how I want you guys to do these. For number 4, what I want you to do is I want you to change this one to square root of 3. Okay, so here's, what R is, you guys. R is real numbers. I should have sort of explained that. So all numbers are real, and then they are either rational, which is Q, or irrational, which is Q bar. So all numbers. So in this course in 20-1, 30-1, every number that I throw at you will be a real number. So without even looking at these numbers, if you're in 10C, 20-1, 30-1, all numbers that I throw at you are real. So I always tell my students, when you get this question on a test, you just go mad checking off that they're all real. Then you're going to go through each number, and you're going to say your numbers are either rational or irrational. Like, that's the second thing you do, right? So that's rational, that's irrational. So 1/3 is a fraction. What did I say fractions are? They are rational. This guy, nice big number, rational. This guy, rational. All our nice numbers are rational, right? This guy, repeating decimal, it is irrational, right? This guy, terminating decimal, it can go into a fraction. This guy's rational. Um, this guy, square root of 3, looks ugly, stays ugly. That guy's irrational. Remember, if your number is irrational, this guy is done, right? I don't have to do anything else with that, because if your number is irrational, there's nothing else to do, right? Negative pi. Pi is your most famous irrational number, and they just want you to put a negative in front of it. That guy's a fraction, rational. Negative square root of 49. Okay, let's see what this guy would be. Negative square root of 49. Oh, whoops, negative square root of 49 is negative 7. So always write what the number is. And let's figure out what this guy is. Square root of 0.16, 0.4. Okay, so this guy is a terminating, and it would go into a fraction. That guy would be rational. This guy is rational because it's negative 7 over 1. This guy, what is this? Okay, I know that this 0.4 is terminating. It's rational. 2, 3, 2, 4, 2, 5. Okay, what do you guys think? There's a pattern. I know the next is going to be 2, 6, 2, 7, 2, 8, but it's not repeating and it's not terminating. So this guy's irrational. Okay, any of the ones that are irrational, you're done, right? Because all numbers are real. All numbers are real, and then they're one of these two categories. If they're irrational, they're done. If they're rational, you do have to check if they're whole, natural, or integer. So remember that they can't have fractions. So let's write no fractions. So for example, this guy, I'm not even going to type it in my calculator. It's going to be a fraction. It's done. This guy is a huge number, but it is a kid's counting number. It's a natural number. It is a whole number because it includes 0, and it is an integer. This negative is just an integer. This guy is a decimal. I'm done. Decimal. I'm done. You're done. They're rational, but they're done, right? These guys are done. These ones, if they're irrational, I'm done. Okay, I have to look at these 3 now. It's going to be a decimal, right? Negative 355 over 113 is a decimal, so I'm done. This guy, what's negative 7? It is also an integer. This is a decimal. I'm done with decimals. And this is a decimal. I'm done. If they're decimals, they are not natural, whole, or integers. Okay? And then the last number that I want you to do, I think, was number 14. So I want you to do 14, and I want you to think of money. Oh, I might have to show you a couple things for this. Actually, yeah, you know how to enter the cube root of 50. So just to show that again, I'm going to clear this. Math button, number 4, cube root of 50. How much money is that? $3.68. This is just 5 root 10. This guy here, 5 and the cube root of 10, how you would enter that, you could either do it one of 2 ways. 5 times the math button, number 4, the cube root of 10, $10.77, or 5 math button, number 4, $10.77. And then $10.70, 0, 2, 4, 6, 8. Okay, so each hatch mark is going up by 2. So $10.77, let's say, is approximately right there. That would be 5 and the third root of 3. No, third root of 10. And then this guy, the third root of 50, $3.68 would be about here. Because if that's $2, that's $4. This would be the third root of 50. Okay, and that's your lesson.